Trigonometry Honors, Lesson 6.2, Trig Functions and the Unit Circle continued. We're actually kind of done with the unit circle. Hopefully you got it, because it's a tricky concept. But now we have other things that might be on the unit circle or just drawn in that coordinate plane. I'm going to draw some stuff and erase because I want to do the problem. But when I tell you to draw something in standard position, in the first quadrant it looks like this. Actually, I'll leave this one up. I'll somehow fit the rest on there. In the second quadrant it looks like this. And I'll tell people always put the theta closest to the x-axis, between the x-axis and the hypotenuse. And then they'll draw it up here or here, or, somewhere out here or whatever. And it makes me a little crazy because it's pretty obvious. It works. I mean, it's not really a, secret or anything. I'm not trying to cause problems. I am literally trying to make your life as easy as possible. And people either don't want to listen or they just can't fathom what I'm saying. So it's a little tricky, but draw a line segment to 5, -12. That'll put me in the fourth quadrant, so I just draw that quadrant. Down over, always to the closest x-axis. Notice I even bolded it. And then we draw in the pieces. 5 over, 12 down. Which makes sense. It should be negative there. So y-axis in the fourth quadrant, a y-coordinate in the fourth quadrant should be negative. A squared, b squared, c squared, 13. And now this is actually not such a bad problem. Sine of theta is -12 over 13. Again, then I'll do my cosecant right away. -13 over 12. Cosine of theta equals 5 over 13. Secant of theta equals 13 over 5. Tangent of theta equals -12 over 5. Cotangent of theta equals -5 over 12. So these problems get a little bit tricky, but they're not that bad. People get lost on where to put the theta, always between the x-axis and the hypotenuse. Hypotenuse always comes out from the origin. Opposite side always goes back to the x-axis. It's right here. Tattoo it on your wrist, whatever it takes. So here's the same idea. Secant of theta, which I don't know anything about. I'll throw it out over here. Cosine of theta, secant of theta. I cannot remember secant of theta. I always say that secant and cosecant and I don't get along. Secant and I met at a party, and he was wearing the same shirt as me, so it got awkward. And then cosecant stole one of my girlfriends from high school, so we don't talk. But I do talk to secant's other friend, cosine, and I know that cosine and secant are flips. Reciprocals, inverses, I don't know, nor do I care. Reciprocals, I guess. Oh, cosine is -3/4. I know that one. That's easy for me. Third quadrant, theta. Cosine's adjacent, 3 over hypotenuse, 4. What happened to the negative? Well, we'll get to that. Always positive. The hypotenuse is always positive. And again, I get people slapping negatives all over the place. We're in the coordinate plane, people. This has to be negative. I don't know what this is. It's got to be negative. And boy, I thought for sure there's going to be a 3, 4, 5, but I just followed the rules. Phooey, 16 minus 9 is, I think that's root 7. Let me check. Root 7 squared is 7. 3 squared is 9. I sure hope you know the negative squared away. 9 plus 7 is 16 squared root. Yeah, it looks like I got it right. So now I can do the rest of them. Sine of theta is -root 7 over 4. Cosecant of theta is -4 root 7 over 7. Tangent of theta is root 7 over 3. Hey, what happened to the negatives? Cotangent of theta is 3 root 7 over 3. Hopefully you notice the negatives canceled. So this is something that's done a lot, and I see it done with formulas and this and that. I really want you guys to graph and look at a picture. Picture's worth literally 1,000,000 words, 1,000 words, I don't remember the quote. It is so much easier. Just lock it down and crank it out. Now here's the hard part. What about a spot right on the axis? So find the 6 trig values for 0, 1. Oops, I lied. We're still doing unit circle. because I know what's going on here at the unit circle. Sine is 1. Well, what if this was 2? Doesn't matter. I am on this quadrantal, whether it's a unit circle or bigger. Sine, cosine, and tangent are all the same along that line. Sine of theta is 1, therefore cosecant of theta is 1. Cosine of theta is 0. I hope you know what secant of theta is then. Undefined. Tangent of theta is sine over cosine, y over x, 1 over 0, undefined. Cotangent of theta is 0. So for the quadrantals, just think unit circle. What's going on in that spot in the unit circle? That's it. There's another concept called the reference angle. It's important when we had charts for 6 trig values. It's kind of nice to tie the unit circle together so you don't have to bother memorizing the whole thing. You bother memorizing one quadrant and then go from there. There's these huge math books, for lack of a better way to put it, CRC I think it was called. And it had all these charts from 0 to 90 for sine, cosine, and tangent out to like 3 decimal places. Crazy stuff. So what it's saying is these angles are really, really similar. 30 degrees and 150 degrees. And why? Well, if you think about it, the coordinates here are negative root 3 over 2, 1/2. And the coordinates here are root 3 over 2, 1/2. So you can see that sine's the same, which means that cosecant's the same. Cosine is the same except for the negative. I mean, this is what a reference angle is telling you, is that these angles are the same except for the negative. In some cases, they're actually the same, which is going to cause us some serious headaches when we get to ambiguous case law of sines. But we'll talk about that later. So you got to take a reference angle. It's drawn to the oh, this sounds familiar. Drawn to the closest x-axis. And you can pull all the values you know for 30 degrees and then just worry about the signs, which I'm going to talk about in a second. Always draw to the closest x-axis. 311 degrees. Reference angle is 49 degrees. Boy, I sure hope that's right. 50 and 10 is, yeah. All right, that's how we do a reference angle. People get hung up on it. There's really nothing that big a deal. I told you I'd talk about the signs, so here we go. Everything is positive up here. A stands for all. Sine, cosine, and tangent. I'm not doing cosecant, secant, and cotangent. They're the same sign. They're all positive. S stands for sine, meaning that cosine is negative and tangent is negative. T stands for tangent. Tangent is positive, meaning sine is negative and cosine is negative. C stands for cosine, meaning cosine is positive, sine is negative, tangent is negative. There's mnemonics written. They're really terrible. All students take calculus. I've had all sorts of weird mnemonics thrown my way. None of them are really all that good. But ASTC. Use it. Remember it. It'll save so much time. Find the 6 trig values for 60 degrees. 60 degrees, we're looking at 1/2 root 3 over 2. So sine 60 root 3 over 2, cosecant of 60, 2 root 3 over 3, cosine of 60, 1/2, secant of 60, 2, tangent of 60, root 3, cotangent of 60, negative root 3. Whoops, sorry, I meant to ask you for 300. Huh, well, let me think about that. 300's here, and the reference angle is 60 degrees. So go down here and say, keep the cosine positive. These are good. And then just change these to negative. I don't know why this was negative in the first place. It should not have been. My bad. That's how you use reference angles. You don't really need them if you memorize unit circle. Great. But they can help you memorize unit circle. Recognize as you spread out from the x-axis, all the signs top and bottom are the same. Be aware. Save you so much time and aggravation. That's about it. Happy mathing.